So today we are going to see the first program, namely generation of periodic signals using MATLAB. So this is your MATLAB online, which opens up. So in the top left, we have a new tab where we can use it to create a new MATLAB program. And if there is an existing file which you want to open, then open this one, and then you can load any file from the already stored experiments. So, and you have a save button where you can, after typing your commands, you can save your program. So today's program is generation of periodic signals. So I have typed the commands here. So the first three lines, like clear all, clear screen, and close all, are used to clear whatever variables are already available. And then in the display window, if there are any already written material, that also will be cleared. So, and also notice that I've used a percentage symbol here. Whatever appears after this percentage symbol is treated as a remark, and it will not be executed in your MATLAB program. So now the program starts here. I have set the variable fs, that is the sampling frequency, to 10k. 10k hertz. I have set it here. Then the next one, I have to like define a time frame in which I have to draw the waveforms. So today's experiment is drawing a periodic signal. So for that, in based on the sampling time, where I should start the t and where I should end this t, and what is the step size in which I have to use this t variable I have specified here. So the first one is the starting value, second one is the step size in which I have to proceed, and the last one is the final value up to which I have to do the plotting using t. So I've used three commands which is straightforward, available in MATLAB, to create a sawtooth wave, square wave, and a sine wave. So I have assigned these waveforms to a variable, namely x1, x2, and x3. So inside this command is there in MATLAB, and then inside I have to specify the frequency, which is 2 pi fs, 2 pi fs. So here I given 2 pi 50. I will take it as a normal value. This t will vary in the manner which is specified here, that is in step sizes I have specified here. Similarly, for a square wave, I will plot 2 pi into 50. This 50 can be anything, you can change and see. Multiplied by the t value is the step size. Here also the range you can change, as well as the sampling frequency you can change and see what is happening. So now I have generated three periodic signals for a square wave, sine wave, and a sawtooth wave. Now I want to plot it and see how it appears in the output. For this I am using a command called as subplot. So the subplot command will divide my output area into whatever number I am specifying here. So the first one is the number of subplots I want to create. Um, I want to create, and this the other two variables is which column that it should be plotting and which row it should be plotting. So in this case, I am allotting only one column, and in the row one, I want to plot my sawtooth waveform. So the command will go like this: the subplot, I am dividing the plotting region into three and one row. In the first one column, and in the first row I am plotting t versus x1, where x1 t is the time slot which we have assigned, and x1 is the waveform which I have used. And we can also define an axis value, where we can specify the x-axis and y-axis value, which is done here. Also, labeling or naming those axes is possible. So x-axis I call it as a time, and y-axis I'll call it as an amplitude. So, and also we can fix a title for whatever we are drawing by the command title. So the first part of plotting the sawtooth waveform is over. Second one, I will try to plot the second waveform, namely the square wave. All other things are same except that now if you observe, I've used subplot 3 comma 1 comma 3 where I have divided the display area into three, the first column and the second row. So the previous one we have plotted in the first row, now I am plotting in the second row, and in the plot command I am using the same variable t, but now I am plotting the square wave. So I use the variable x2 which I had assigned for the square wave, it is here. So here if you see x1, x2 and x3 are assigned the three waveforms, the second one I have plotted. So and lastly, we want to plot a sinusoidal wave. I will use the third row for plotting this, namely 3 comma 1 comma 3, and the plot is going to be t versus x3, where x3 is my sinusoidal wave which I calculated. Here also I can specify my axis values, starting and ending values, and then a label also can be assigned and a title for the same. So once the program is completed, we go to the run tab which is available here. Here you will see save and run, which means I can save the program. So I'll run it. So now if you see, I'm getting a figure here. So these are the outputs of generated by my subplot command. It has divided the entire screen into three rows and one column. First one I have plotted the sawtooth waveform, second one the square wave, and third the sinusoidal wave. So try to do it and see for various, maybe you can alter the sampling size or the type of waveform you can alter. Try to find out if you can plot any more periodic signals. Thank you.